All right, everybody, welcome back from break. Hope you had an awesome break and enjoyed time with your family. I know I did. I am on Chapter 5, Lesson 3, so 5.3, page 209. Please follow along. Remember, focus, can-do attitude, take initiative, and listen carefully. At any point, pause the video, rewind the video, raise your hand if you have any questions. Okay, let's get to it. Okay, Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels. He wants to arrange the coins into rows. We need to make rows. Each row will have the same number of coins, and all the coins in the row will be the same. All the coins in a row will be the same. How many coins can he put in each row? That's our question. So remember, we always want to come back and make sure we answer the question. Okay, so let's kind of organize our information by using this graphic organizer. So what do I need to find? I need to find how many coins can be put in each row. How many coins? How many coins that can go in each row, so that each row has, and we see right here, so that each row has the same number of coins right here where we highlighted, same number of coins. So that each row has the same number of coins. Okay. Oh, whoops. Let me go back. Previous. Okay. Sorry about that. I lost you there for a second. Okay. What information do I need to use? Well, I need to use how many coins he has and how many of each kind of coin. So Chuck has, and we see at the top, 30 pennies. And I'm listing more than 3 or more things, so I need to use commas. 24 quarters. Sorry about that little line there. Comma, and 36 nickels. Okay, each row has the same number, whoops, should be an N, number of coins. Okay, oh, did it again, lost you, sorry. Okay, how will I use this information? I can make a list to find all the factors of those 3 numbers of 30, 24, and 36. Then I can use the list to find the common factors. A common factor is a factor of 2 or more numbers. Okay, so let's make our factors. I can list the factors of each number, then I can circle the factors that are common to all 3 numbers. Okay, so let's find the factors of 30. I can do 1 times 30. Can 2 work? Let's see, 2. Well, I see that 30 ends in a 0, 2, 4, 6, or 8. So I know that 2 will work. How many times? 2 times what is 30? Or I can take 30 and divide it by 2. That's 15. Okay, what about 3? Well, I know 3 will work because 3 plus 0 equals 3. And 3 can go into 3. So I know 3 can also go into 30. 3 times 10. Okay, what about 4? Well, if I jump up to 40, I know that's too big, but I take 4 away, that brings me down to 36. I take 4 away again, that brings me down to 32. I take 4 away again, that brings me down to 28. That I'll I'll never land on 30 if I count by 4, so 4 is not going to work. What about 5? Yeah, 5 will work. 5 times 6. Okay, what about 7? Well, let's count by 7s really quickly. We can count by 7s up here. 7, 14, 21, 28, 35. Nope, I'll never land on 30 if I count by 7s. What about 6? Yep, 6 works, and I already found it right here. So that's, once you've come back around and you start finding numbers you've already found, that's when you know you're done. Okay, so that's all the factors of 30. Now I'm going to give myself a little more room, so I'm going to do 24 over here. Okay, I'm going to start by 1 times 24, of course. That'll always work. And then 2, I can see again, 24 ends in a 0, 2, 4, 6, or 8. So my divisibility rules tell me that 2 will go into 24 evenly. And if you know your 12s, it's 2 times 12. Okay, what about 3? Well, again, my divisibility rules tell me that 2 plus 4 is 6. So if 3 can go into 6, then 3 can go into 24. And I know 3 can go into 6 twice. So I know 3 is going to work. I just need to figure out how many times. Well, you can see up here, I had 3 times 7 was 21. So if I do another 3, that would be 24. So that would be 8 3s. 3 times 8 is 24. Okay, what about 4? Will 4 work? Well, I'm going to jump to a benchmark that I like to use. I like to use 10 and 5s for my benchmark, just a quick check. So if I do 4 times 5, that's 20. So I'm very close to 24 already. So if I do 4 times 5, that gets me all the way up to 20. And then I can start adding 4s from there. And yep, I get right on to 24. So I had 5 4s here, and then I added 1 more 4. So I used a total of 6 4s. So 4, it's supposed to be a 4, times 6 will give me 24. Okay, what about 5? Well, let's count by 5s. 5, 10, 15, 20, 25. Nope, never will land on 24. What about 6? Yep, 6 works, and I already used it, so I know that tells me now I must be done finding all the factors of 24. All right, let's go to the next one, 36. I'm going to give myself some space again. And here, let me erase some of this. Again, you can rewind if you need to see those marks. 36, okay. I can do 1 times 36, of course. What about 2? Well, again, I know 2 will work because the number in the ones place is a 0, 2, 4, 6, or 8. So I know 2 will work. Well, half of 30 would be 15. Half of 6 would be 3. So that's going to be 18. Using my divisibility rules again, let's check if 3 will work. Well, 3 plus 6 equals 9. And 3 can go into 9, so I know 3 will also go into 36. And again, if you know your multiplication facts, you know it's 3 times 12. Okay, what about 4? Will 4 work? Well, earlier we did 4 times 10 to jump up to 40. If I take, so 4 times 10 equals 40, well, that's too big, but if I take one of those 4s away, now I'm at 36. So not 4 10s, but 9, not 10 4s, but 9 4s will get me to 36. And again, if you know your multiplication facts, then you already knew that. You didn't need to wait for me. Okay, what about 5? Well, count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Nope, I'll never land on 36. Okay, what about 6? Well, 6, 12, 18, 24, 30, 36. Yeah, 6 times 6. Okay, what about 7? Well, earlier, look, I already counted by 7s earlier, so I don't need to do it again. 7, 14, 21, 28, 35. If I add 7 more, that's going to be 42. I'll never land on 36. Okay, what about 8? Well, let's try it. Let's count by 8s. 8, 16, 24, 32, 40. No, never land on 36, so 8 won't work. What about 9? Well, yeah, 9 will work, but I already found it. See, it's right here. So that's once I get back around and I start finding numbers I already found, I know I'm done. So now I found all the factors. So now I just need to find the common factors. So I start looking in each one of these rows for numbers that they have in common. So I see a 1 here. Oop, lost you for a second. Let me go back. Okay, here we go. Got 1 here, I got a 1 here, I got a 1 here. So they all have 1 as a common factor. Okay, I got a 2 here, 2 here, and a 2 here. So they all have 2 as a common factor. 3, 3, 3. They all have 3 as a common factor. What about 4? Well, I see a 4 here, I see a 4 here, but there's no 4 here. So no, 4 is not a common factor of all 3 of them. What about 5? There's a 5 here. No 5s. Okay, what about 6? Well, yeah, I see a 6 here, I see a 6 here, and I see a 6 here, and there's actually a 6 on that side too. But as long as they have 1 of them, then I know 6 is also going to be a common factor. Sorry about that. All right, what about 7? Well, no, there's no 7. 8, no 8 there. 9, no 9 there. 10. I see a 10 here, but no 10s in the other ones. 11, no. 12, no. 13, no. 14, no. 15, well, there's a 15 here, but not in the other ones. 16, no. 17, no. 18, 19, 20, no. Okay, I think, looks like we found them all. Okay. All right, so the common factors are 1, 2, 3, and 6. So what that tells me, let's go back to our question now, because we want to understand what those numbers mean. How many coins can he put in each row? If he wants the same number of coins in each row, okay, and he wants each row to have the same type of coin, he can put them all in rows of 1. He can put them all in rows of 2. He can put them all in rows of 3, or he could put them all in rows of 6. Okay, that's what that tells us. All right, thanks again for watching, and I'll see you on the next video.